So, hello everyone again. This is the first lecture on alternating current. Today we will be starting with a new lecture series that is based upon alternating current. As the name suggests, there are two types of current, one is direct current, one is alternating current. Alternating current basically means that the current is in a sinusoidal form or in a wavy form. So, basically for some portion of time it is positive, for some portion of time it is negative. So, we will understand different concepts regarding all this current, why it is necessary, why are we not only and only satisfied with direct current and all. So, let us begin the discussion directly. So, this is lecture 1 part 1 of alternating current. I am Sameer Lavankar. Let us begin our discussion. Okay. So, first of all an introduction course outline for you. So, let us not go into discussion further, let us just start today with introduction and then we can move forward with our subsequent lectures. Okay. So, introduction regarding this chapter. Okay. So, we have so far considered direct current sources and currents with DC sources. So, basically what is DC source? As in the name suggests, let us suppose I make this diagram in which this is your current and this is your time. So, basically let us suppose that if a particular constant value is being applied, if a constant value is being applied which is let us say in positive sense only, then that is called as your direct current. Okay. So, direct current as in these all things were already understood in previous lectures and previous chapters. Today in this chapter we will start with alternating current. Okay. So, these currents do not change direction with time, quite evident, as you can see there is no change in direction, as in direction here means that let us suppose that in some sort of sense it will go down. So, this will not happen in this case scenario. Next thing is, but voltages and currents that vary with time are very common, which are basically your alternating currents. Okay. So, they are abbreviated as AC. So, the electric main supply in our homes and offices is a voltage that varies like a sine function. So, if you remember correctly, what is a sine function? Sine function is a wavy type of nature or sinusoidal form of nature in which for some part of the time, let us say the x axis is time, it is in the positive sequence and for some part of the time it is in negative sequence. Okay. So, the electric main supply in our homes and offices is a voltage that varies like a sine function with time. Such a voltage is called alternating voltage. Please remember it is alternating voltage or it is also called as AC voltage. So, basically if voltage is what we can say, if is it a difference for some time, is it is positive for some sequence and negative for some sequence, then it is called as alternating voltage, and similarly the same definition is also given for current. So, and the current driven by it in a circuit is called as the alternating current, that is AC current. Okay. So, this is a normal definition regarding your AC voltage and AC current. Today most of the electrical devices we require use AC voltage. So, everything, most of the electrical appliances such as AC, computer or let us say all power supplies, monitor, CPU etc. works upon AC voltage only, washing machines, everything which you can think of, all the big appliances which work today in daily life sequences works upon AC voltages only. So, why it is necessary, why do we depend more upon AC voltage and not directly on DC voltage? So, this is mainly because most of the electrical energy sold by power companies. So, everything comes through electrical supplies, electrical power lines. So, basically where are these power generated? They are generated through power companies. So, this is mainly because most of the electrical energy sold by power companies is transmitted and distributed as alternating current. So, because they only distribute it as alternating current, we basically use it as alternating current or basically alternating voltages. Fine. What is the main reason? The main reason for preferring use of AC voltage over DC voltage is that AC voltage can be easily and efficiently converted from one voltage to the other by means of transformers. So, transformer is the last topic which we will study in this chapter. So, we will basically understand what is the basic agenda or basic principle of using a transformer, what is a step up transformer, what is a step down transformer, how is the voltage being changed in this, what is the basic physics behind transformers and so on. But just to understand now, the crux is what is the main reason of using this AC voltage is that one voltage or let us say a less volume of voltage is being converted into a higher efficient form of voltage which can be directly implemented, or basically how to change this power line supply to a less supply which we use in our home appliances is basically through the use of a transformer. Okay. Further, electrical energy can also be transmitted economically over long distances. So, basically this is one of the disadvantages which we generally see direct current or direct voltages, and that is why AC voltages are commonly used or majorly used for your transfer of current or power from one place to another place which is at a long distance or far off distances. Next thing is AC current exhibits characteristics which are exploited in many devices of daily uses. For example, so what are the examples of these? Whenever we tune our radio to a favorite station, we are taking advantage of a special property of AC circuits, one of which we will study in this chapter. So, basically that property is nothing but resonance, which we will study in the subsequent parts of this lecture series only. So, that being said about the introduction part, let us now dive directly into the first topic, that is AC voltage applied to a resistor. So, in the previous chapters, previous discussions in 11th and 12th chapters, what were the basic devices which we understood regarding electricity? The one was your basic resistors, then a concept of charges was being explained to you, in which we understood capacitors, and then about inductors was being explained. In this we will try to combine, first we will try to understand each of these devices individually, as in what happens when an AC voltage or AC current is being supplied to these all devices, and then we will try to combine them. So, we will do first R, then C, then L, then RC or CL or LC sort of that, and then we will move on to finally the combination of all of them, that is RLC circuit. We will try to understand all of these things, then we will move on to the application of this part, and that is the complete discussion regarding this chapter. Okay. So, that thing being said, now let us move on to the first concept in this chapter, that is AC voltage applied to a resistor. Fine. So, as you can see here, so it is very easy diagram to be made here. So, this is basically an EMF being applied, which is an alternating current. This sign which you see is basically used for an alternating current to show that an alternating current is being supplied to the circuit, or basically an alternating voltage type of EMF is being supplied through the circuit. This is the general reference or general sign which we use for a resistor. So, basically a single resistor is being connected, and general assumptions are that there is no internal resistance in these wires and so on. Only and only resistor or only and only device which provides you with resistance is this resistor with a resistance of R ohms. Fine. So, let us dive into this concept now. So, AC voltage applied to a resistor. So, here as you can see that figure shows a resistor connected to a source epsilon of AC voltage. So, this is basically the EMF of the voltage. The symbol for an AC source in a circuit diagram is this. We consider a source which produces sinusoidally varying potential difference across its terminals. What does it mean? So, basically anywhere when you listen to the word sinusoidal, it should basically be understood such as a wave which has, for some part of the time it is in positive sequence, and for some part of the time it is in negative sequence. Okay. So, basically it is a source which produces sinusoidally varying potential difference across its terminals. Let this potential difference also called as AC voltage. So, now we are trying to basically mathematically try to define something, so that what is basically the voltage produced or what is basically the current produced and so on. So, let this potential difference also called as AC voltage be given by V is equal to Vm sin omega t. So, why it is sin omega t? Because we have understood that the complete concept of AC voltages can be understood using sinusoidal waveforms. Sinusoidal waveform, the best example to implement is sine, cos and tan, but in a very easy sequence we generally use sin omega t. So, let us start with sin omega t. So, what is basically happen if I try to explain you with a graph. So, let us suppose this is time t and this is the voltage. So, basically a sinusoidal waveform sort of this would happen. What is Vm here? Vm is the maximum value of the voltage which is being obtained, and so basically this is how the diagram is being made here. Fine. So, this is basically V is equal to Vm sin omega t. Moving forward with the discussion. Okay. So, where Vm is the amplitude of the oscillating potential difference and omega is its angular frequency. So, omega is its angular frequency, which is 2 pi nu or 2 pi f. Okay. Next thing is to find the value of current through the resistor, we apply Kirchhoff's loop rule. So, basically in the concept of current electricity, we have understood Kirchhoff's loop rule, which states that in the entire circuit the summation of all the resistances or the potential differences is equal to 0. So, just doing that concept here, applying that concept here, we will get a summation of all the EMFs across the complete time in a particular loop is equal to 0. So, using that, what we basically see that the complete potential difference across this is being transferred into this. So, basically we can directly equate all these sequences. Okay. So, what is the potential difference across this? The potential difference across this will be nothing but the current flowing in the circuit multiplied by R. So, this is a basic sequence which you also understood in the current electricity chapter, and what is basically the voltage here, that voltage is basically V. So, we know that V is equal to IR, correct. So, let me just keep on writing here. So, basically what is happening here, using now, as we already know that what is V, V is basically Vm sin omega t, which is equal to IR, correct. So, what is the current flowing in the circuit? The current flowing in the circuit is nothing but Vm by R sin omega t, which is being explained here. Okay. So, basically what we got till now is the current flowing through the circuit, current flowing through the AC voltage circuit which only have a resistor is I is equal to Vm by R sin omega t. So, as you can see that if I say that what is Vm? Vm is a constant value for a voltage being supplied, capital R is a constant value. So, basically what is I? I is also a sinusoidal waveform which changes with time. So, basically if I draw a diagram for this also, because the diagrams are very important here. So, let us say this is the current I am explaining to you, and let us say again make a waveform. This time the amplitude will be nothing but Vm by R. So, this is how we can understand the current. Fine. Moving forward. So, since R is a constant, we can write this equation as nothing but I is equal to Im sin omega t. What is Im here? Im is basically, we can remember this Im as Vm by R. Okay. So, the current amplitude, which is this Im is nothing but current amplitude. So, which is given by Im is equal to Vm by R. Okay, quite evident. Normal description is being implemented here. Now, this above equation is just Ohm's law. So, we know that what is Ohm's law? Ohm's law is nothing but, we have already understood that is nothing but V is equal to IR. How it is being obtained? So, when we are trying to understand the concept of resistors in current electricity, we said that what is voltage? Voltage is directly proportional to I, and through which we obtain this result that V is equal to IR. So, this is nothing but just an explanation of how these things came, and this is already being derived. So, they are just trying to implement that this all things are directly linked up. Okay. So, above equation is just Ohm's law, which for resistors work equally well for both AC and DC voltages. So, this work for AC voltage also, this work for DC voltage also. What will be the difference? The difference will be only that in AC voltage there is a sinusoidal waveform. So, a sin omega t value may come, but in terms of DC voltage there will not be any value, the Im or Vm value will be constant. Okay. Next thing is the voltage across a pure resistor and the current through it are plotted as function of time as shown in the figure. So, as you can see here, so basically this will be your, this blue figure will be the waveform or the graph for the difference or the variation in the value of voltage with time, and as the current Im is nothing but Vm by R, which is a little smaller than Vm. So, current can also be obtained in the same waveform. Okay. If you see clearly, both of them have the same period, and next thing is that they both are also aligned, as in the starting point of Vm is also the starting point of Im, and the ending point of, let us say this is the ending point. So, let the ending point of Vm is also the ending point of Im. Why I am trying to stress upon this point, because for the change concepts of capacitor and inductor, this will not be the same, that is why. So, just try start remembering from this point only. So, if you see clearly, both of Vm, or basically both the voltage and the current are in phase. What does it mean by in phase? In phase basically mean that the starting point and the ending point of both voltage, basically AC voltage and AC current, are same. This is nothing but also called as your that voltage and current are in phase. Okay. So, note that in particular that both V and I reach 0 minimum and maximum values at the same time. Both reach 0 minimum and maximum value at the same time. Clearly, the voltage and current are in phase with each other. So, this is the concept of basically in phase. Okay. What if something is not in that, in this sequence or in this form, then we say that both current and voltage are out of phase. Okay. So, this was simple definition of what is in phase and what is out of phase. Now, we see that like the applied voltage, the current varies sinusoidally. So, quite evident, you can see that the current also is varying sinusoidally and has corresponding positive and negative values during each cycle. So, during this cycle it is positive, during this cycle it is negative. Okay. Next thing is, thus the sum of the instantaneous current values over one complete cycle is 0 and the average current is 0. So, if you just directly sum, so basically the area of this plus the area of this would come out to be 0. Thus, the sum of the instantaneous current values over one complete cycle is 0 and the average current is 0. Fine. The fact that the average current is 0, however, does not mean that the average power consumed is 0 and that there is no dissipation of electrical energy. This line is very important. So, basically how is the sum of current being calculated? The current sum is basically, if you try to just capture the area under the curve. So, you can clearly see that the area under the curve or the summation of the area under the curve is 0. But how is power calculated? Power is calculated some sort of in this sequence, as in if you try to calculate the value of area, let us say the average value of f, then that average value of f is nothing but equal to 1 by f integral f dt, 1 by t over the complete cycle integral f dt. I will try to explain you how this thing comes, and then we can finally see that the power consumed is not 0, but the total summation of current is equal to 0. Okay. So, that thing is only been explained here, that the fact that the average current is 0, however, does not mean that the average power consumed is 0 and that there is no dissipation of electrical energy. So, there will be dissipation of electrical energy, but that cannot be sequenced using the same concepts of scalar, let us say, multiplication. Some sort of integration is being explained there. So, as you know, Joule's heating is given by I square R and depends on I square, which is always positive, whether I is positive or negative. So, as I square, because it is I square, so basically anything which is implemented in this downward cycle also will be positive only, and so everything will be added up. So, it depends on I square, which is always positive, where I is positive or negative and not on I. Thus, there is Joule heating and dissipation of electrical energy when an AC current passes through a resistor. Okay. So, there is Joule heating, there is dissipation of electrical energy when an AC current passes through a resistor. So, I think let me stop it here only. In the next class, I will try to explain you the concept of this complete instantaneous power being dissipated. So, in this lecture, we have understood the introduction part, and basically the AC, how is AC voltage applied to a resistor changes the value of current, or what is the basically the derived value of current, and how is power being generated. Instantaneous power derivation will be explained in the subsequent class. So, let me stop it here only, and then we can start the discussion in the next part. So, thank you so much.